Okay, so magandang araw sa inyong lahat. So this will be our slides and lecture on some examples concerning ISR evaluation. So that involves yung ISR overhead at saka yung ISR CPU percentage. So recap lang, yung ating main equation is actually just this one. So ISR percentage equals ISR instructions times yung frequency ng ISR over the instruction frequency times 100%. Or alternatively, see instructions per ISR divided by the instruction frequency gives us the execution time or time it takes for each ISR. So let's get right into it. Our first example is just on some sample computations. So consider a timer interrupt that is configured to occur every 10 milliseconds with an ISR that finishes after 71 instruction cycles, which includes the context save and restore. So after or in addition, there is a change notice interrupt with an ISR that finishes after 508 instruction cycles. So this is also including context save and restore. And this is yung change notice interrupt na to is connected to an input that changes state 5 times per second on average. So assuming an instruction frequency of 8 megahertz, compute for the following. So medyo straightforward lang naman yung sa atin. So let's just summarize yung ating given. So we have a timer interrupt configured to occur once every 10 milliseconds and finishes after 71 instruction cycles. So ang FISR yung ating timer interrupt is 1 over 10 milliseconds. And ang kanyang instruction count ay 71. Then for the change notice interrupt, it finishes after 508 cycles and then 5 times per second. So 5 times per second, 508 instructions per ISR. Then the instruction frequency natin is 8 megahertz. So if we start with the execution time, so that's just the number of instructions divided by the frequency. Then, so for the timer, it's 71 over 8 megahertz, so 8.875 microseconds. So for the change notice naman, 508 over 8 times 10 to the 6, or 8 megahertz, which is 63.5 microseconds. So obviously, mas madaming instructions si interrupt, so mas mataas yung kanyang execution time. Excuse me. So next, let's compute for the ISR CPU percentage. So ISR CPU percentage, if we are given the execution time, i-multiply lang natin siya dun sa frequency ng ating interrupt. So for the timer, so 8.875 microseconds times ang 1 over 10 milliseconds is 100 times 100%. And then si change notice naman, 63.5 micro times 5, 5 per second. So 100%. So computing this, ayon si timer ISR percentage is nasa 0.08875. And then si change notice naman is nasa 0.03175%. So, ayan, you'll notice here, mas mataas yung execution time ni change notice interrupt, but the timer interrupt occurs more often, so mas malaki yung CPU percentage niya. Pag pinagtabi natin silang dalawa. So, if you're considering sino yung gusto nating i-improve, it might be the timer interrupt kasi mas malaki yung effect niya doon sa ating CPU percentage. Okay. Next example is an example which utilizes the shadow register set as sa kanya question. So a comparator interrupt takes 96 instruction cycles to service and enables a timer interrupt that triggers twice before being disabled Again, so every time na magkaroon ng comparator interrupt, meron tayong dalawang timer interrupt. So the timer interrupt takes 69 instruction cycles to be serviced naman. So assuming there is only one shadow register set na pwedeng gamitin, and it can reduce the either ISRs by 10 instructions in total, let's identify the following. So first is to find the minimum combined ISR CPU percentage that could be achieved in terms of the frequency of the comparator interrupt if the instruction frequency is 8 megahertz. So ano yung combined na ISR CPU percentage? Syempre, since hindi given yung frequency ng comparator interrupt in terms of that yung sagot. So the other question is if the timer interrupt could be reduced to 46 instructions, which interrupt should use the SRS naman for a lower CPU percentage. So basically, parang investigation lang kung sino dapat yung gumamit ng shadow register set to improve the overall CPU percentage usage ng ating interrupts. So again, let's just simplify yung given. For the comparator, yung instruction frequency ay yung interrupt frequency hindi given, so let's just say X or any other letter. Then yung instructions na kailangan niya is 96. Then for the timer interrupt, twice ng frequency ng comparator, since every comparator trigger means two interrupts ng timer. Assuming na walang ibang source or walang ibang mag-activate sa ano. Then, yung instructions naman for the timer is 69 instructions. Then, assuming an instruction frequency na 8 megahertz, this is the first question. And then yung savings natin, yung reduction in cycles pag gumamit tayo ng SRS is 10 cycles. So, focus tayo sa first question. So, basically, kailangan na natin ma-compute yung ISR CPU percentage if gamitin natin SRS sa comparator or gamitin natin SRS sa timer. So let's first consider the case na comparator, yung gagamitan natin ng SRS. So for computing the ISR percentage, ayun, di ba, instruction count times frequency ng interrupt over yung frequency ng instructions. So same yun for both cases. So si comparator, 96 siya originally, naging 86 since siya yung gagamit ng SRS. And then si timer is at 69. And then times 2 yung kanyang frequency. So just continuing the computations. So for the comparator, it's 1.05 times 10 to the negative 3 times the instruction frequency percent times the interrupt frequency percent, and then 1.725 for the timer. So when we total this, 1.075 plus 1.725, we get 2.8 times 10 to the negative 3 times yung frequency ng ating comparator interrupt. Now, doing the same, if yung timer interrupt yung magsha-shadow register set, which means 59 na siya from 69, and then 96 naman si comparator interrupt. So, ayun, from 1.075 to 1.2 si comparator, and then si sa timer naman from 1.725 bababa to 1.475. And then pag in-add natin sila, 2.65 times 10 to the negative 3 times yung frequency no comparator. So, sino yung mas mababa? Ayun, pag ginamit natin siya sa timer. So, 2.675 times 10 to the negative 3 times yung frequency ng comparator. So, next question natin is, if yung timer interrupt, bawasan natin ng 46 instructions. So, bawasan pa natin siya lalo. Ano yung mangyayari? Sino yung mas better? Mas na better pa. Gamitan ng shadow register set. So, modify lang natin yung computations natin kanina. Ayan, pag ginamit pa rin natin siya sa comparator, 86 siya, and then 46 dito sa timer. And then, ayun, since nang binigay na frequency ng instructions, let's just leave it at that. So, yung total for the comparator interrupt is 178 times yung ratio no interrupt frequency at saka no instruction frequency. Kaya magbinaliktad natin, balik ng 96 si comparator, 36 naman si timer. Ayan, from 96, 72, pag inad natin 168. So, you notice here, kahit isipin mo, ang bilis na nung timer, interrupt natin, 36 instructions na lang siya. But hindi ko siya gagamit, but pa siya yung gagamitin ko ng shadow register set. So, mapapansin nyo dito, since si shadow register set, siya yung mas madalas mangyari, nata times 2 yung reduction natin. So, usually you'll notice pagka ang CPU percentage ang usapan sa pag-evaluate ng ISRs, or ayun, if gusto mong mapababa yung CPU percentage ng interrupts mo in general sa yung system, you'll most probably look for the highest highest frequency na interrupt, and siya yung gagamitan mo ng improvements or yung shadow register set in this case. So, ayun, di ba nilang, kuwari, kahit maging 1,000 si comparator ISR count, parang mas mabilis pa rin or mas mababa pa rin yung CPU percentage overall pag in-apply mo siya dun sa mas madalas mangyari na timer interrupt. But of course, that is under the assumption na yung savings natin is constant na 10. So, sometimes, dumalaki yung savings sa shadow register set pag mas malaki yung ISR. So, in this case, since same lang sila, it's better to use it on the more recurring interrupt. So, ito, meron tayong third problem. Or third example, so medyo word problem siya in a way na para siyang math problem. Kailangan mag-set up ng equation. So, ayan, two interrupts occur at 300 times and 500 times a second respectively. So, if both their ISRs have the same execution time and account for 2% of the CPU time when combined, answer the following. So first is, hanapin yung execution time of both interrupts, and then the second is combined ISR CPU percentage if the instruction frequency is double. So, ayan, execution time of both interrupts. So, paano natin kaya siya hahanapin? So, ang given sa atin is yung 2% ng CPU, yung ISR CPU percentage, yung CPU time. And then meron din tayong interrupt frequencies na 300 and 500. And then another thing na alam natin is pareho sila ng execution time. So when we compute for the ISR CPU percentage of each interrupt, nakalagay. Pero 300 at saka 500, tapos yung execution time nila is pareho T. So pag alam natin, pag in-add natin yung CPU percentage ni 300 sa 500, is makukuha natin is 2%. So, ayun, substitution lang, lagay natin yung dalawang sa taas, dito sa left-hand side. T300, T500 equals 2%. So, and essentially, mawawala yung mga percentage. So, 300 times 100 is 30,000, 50,000. Pag in-add natin, 80,000 T equals 2. So, our execution time is 25 microseconds. So, yun. If you want to check lang, pwede natin i-plug in si 25 pabalik dito sa taas. So 25 micro times 300, 25 micro times 500. Ang result dyan is 0.75 yung sa 300, 1.25 yung sa 500. And pag inad mo si 0.75 at saka si 1.25, makukuha natin yung 2% natin dito. So, ayan. Confirmation lang na execution time nila is 25 microseconds. So, next naman is, ayan, combined ISR if the instruction frequency is doubled. So, ang first natin hahanapin dito, or ang first natin consider dito, kahit bumilis or bumagal yung ating instruction frequency, yung number of instructions natin should remain the same. And yun nga, ang number of instructions natin, pwede natin siya makuha when we multiply the execution time ng isang ISR doon sa kanyang instruction frequency. So parang inverse lang siya nung pagkuha ng TISR. So parang naglipat lang yung variables. So, if yung naunang timer execution ay yung unang interrupt execution time natin is 25 microseconds with instruction frequency na hindi binanggit, ang makukuha nating bagong execution time should be equal doon sa product na to if i-multiply natin siya dun sa bagong instruction frequency na 2fcy. So, isolating yung or finding the new execution time, we get that ayun, 12.5 microseconds. So, intuitive naman, bumilis yung ating execution or bumilis yung ating instruction frequency by 2. So, yung time it takes for us to finish the ISR should be cut in half. So, 12.5 microseconds. So, yan. Parang ulitin lang natin yung ginawa natin sa pag-check kanina. But instead of 25, gamitin natin si 12.5. So, and we get 0.375 sa 300 times per second interrupt and 0.625 naman dito. So, in total, naging 1%. So, you'll notice here, from initially 2% na CPU time, ang for ISRs, naging 1% na lang nung tinasan natin yung instruction frequency. Kasi going back, ang equation natin for CPU percentage, nasa denominator si instruction frequency. So, if ginawa mo na yung lahat, wala ka nang magawa, hindi mo na mabawasan yung instruction count, hindi mo na kayang babaan yung frequency or ayun, parang fixed na yung rate nung pag-occur nung interrupt, hindi mo na mabawasan. Another way to decrease yung CPU percentage is just bilisan mo na lang yung CPU. So, si CPU na lang yung mag-a-adjust dun sa interrupt para mas madami siya ma-service. So, basically, mas magpapakihirap siya para ma-account for ang lahat. So, ayun, siya isang market. So, yun ay ang ating examples for considering yung ISR overhead and latency. So, expect similar questions to this dun sa ating quizzes. So, that's all for this set, and this will be the last video lecture for this week. So, thank you very much, and good luck sa quizzes.